Okay, so here's the rest of your review. I had some issues with the camera, so here's the rest of your review. Fill in the blank. An ionic compound. In ionic compounds, should be ions are formed when bonding a metal and a non-metal. Ions, metal. Okay. Blank are positive ions formed, so cations, because they form a positive, and formed by losing. Oh, we can do a transfer. See if that works. Transfer electrons. Anions are negative ions formed by transferring electrons, and we could say gaining here. Okay, they gained those transferred ones from the cation. Okay, so gaining can go here, and then during this bond, electrons are, well, okay, there's not enough words in there, so transferring. And this one, I was right at first, should be losing electrons. So cations lose electrons, anions gain electrons, okay? And because we're ionic bonding, the electrons are transferred, okay? So on this page, I'm just going to show you, because a lot of what we did here together is the same stuff here, but make sure you have the charges on all of your cations and anions, okay? Make sure you've crossed up your charges here, okay? Number 35, you should have noticed that the this is a little weird. This is actually a covalent compound. It's not an acid, it's water, okay? But don't do anything there. Number 33, you should have noticed that chlorate is a -1, magnesium is a +2, so when we cross those down, it should actually have been a 2 here as a subscript, okay? Over here, notice that the only times I have 8s are with polyatomic ions. The rest of them end in ides because it's just one atom or one element there, okay? Down here at the bottom, make sure you've crossed all your oxidation numbers up and reduced, such as here with PbO2, because we started with a 4 here and a 2. When they cross down, a 4 and a 2 reduced down to, actually it should be the other way, 2 and a 4 reduced down to a 1 and a 2, okay? And once again, make sure you're crossing your oxidation numbers down to get your final formula, okay? So please notice that over here in our names, right, there are no B block metals used in the first couple, which is why there are no Roman numerals in the names that I wrote down, okay? We get Roman numerals down here in these names because iron, lead are both B block metals. Aluminum is not, okay? Also notice that there are no Roman numerals in our formulas. No formulas that are, even the ones that were given, none of these have Roman numerals in them. Their only numbers are in the subscript form, okay? If we come down here, use the table below to answer the following questions. Each element, name each element. So number 1, so when I want to name or identify, I'm purely looking at the number of protons. So number 3 is lithium. So element 1 is lithium because it has 3 protons. Element 2 is magnesium because it has 12 protons. And 317 is chlorine because it has 17 protons, okay? So which element listed is in the form of an ion? So an ion is an element with a charge. So right now we're thinking that all of these elements are going to be neutral because protons equal electrons. Well, when we have an ion, okay, they are not going to equal each other, all right? So we're going to have either more or less electrons than the protons. So I need to look here. Chlorine has the same number of electrons as protons. Lithium has the same number. So those are all neutral elements. If we look at magnesium, it has 2 more protons than electrons, which means it's going to have a +2 charge on it, which means it's lost those electrons. Okay, so magnesium in this example, is your ion. All right. Next one, alkali metals need to give away one valence shell electron to have a full outer shell. Which group on the periodic table wants to readily accept one electron? So which one wants to gain one electron up here? These are going to be your halogens, or group 17, or 7A. All right. List 3 properties of ionic compounds. They have high melting. They are electrolytes when they're in solution. Okay. They transfer electrons. They form ions. High boiling would be one. All right, and a good one is they form a crystal lattice. Okay, they form a crystal lattice. What is the formula for the compound formed by copper 2 ions and chromate ions? So I have copper 2 and a chromate. All right, so I have copper 2, which is going to be Cu, it has a +2 charge, and chromate, that's C, which is CrO4 with a -2 charge. So when I cross those charges up, they cancel out. So it should be CuCrO4. Okay. Notice how I don't put these in parentheses because there's only going to be one chromate, and I don't need parentheses when I only have one. Which of the following is the metallic ion in copper 2 chloride? So which of the following is the metallic, so metal, the cation, and copper 2 chloride. So copper 2 is going to be your metal. This Roman numeral tells me the charge on copper, so this is going to be copper 2, the +2, all right? Oh, no, that's carbon. Ooh. Copper's over here. There we go. Okay. 5, compared to a calcium atom, C+2 ion has what? So when I go from calcium normal to calcium +2, what has happened? All right. So this is an ion, which means it has lost 2 of its electrons. So 2 of its electrons have been kicked off. Nothing with the protons. So it is going to have the same number of protons. Nothing about the protons have we been talking about. All right. So we have same number of protons, but does it gain electrons or does it lose electrons? So it starts off looking like that with its little dot structure. To get to this, it has lost, it's kicked off 2 electrons because these are negative. When you get rid of negative things, you become more positive. So same protons, but less electrons. All right. Next one. Name the acid. So we have a binary acid. So every binary acid has hydro in it, and every binary acid ends in ic, and then we add the word acid. So this is fluorine, so it turns into fluoric hydrofluoric acid. Okay. Next one, H2SO4. This is an oxyacid, which means I should have 3 elements, 1, 2, 3. And in oxyacids, we do not write the word hydro. We do have acid at the end, but we start with a polyatomic ion, which is right there. So because this is sulfate, 8 turns to ic. This should be sulfuric acid. All right, and the same thing over here. This is another oxyacid, and we are dealing with sulfur again, but this is in the sulfite form. And because this is oxyacid, no hydro like we wrote over here, but it still ends in acid. And because this is sulfite, ite turns into us, this should be sulfurous acid. Okay. Next one, name the following acids. So really this should be the formula for the following. So this is nitric acid. So once again, notice how there is no hydro in the name. If it were hydro, it would be binary, but it doesn't. So this is an oxyacid, so which means I need to have a polyatomic ion. That doesn't mean it shouldn't start with hydrogen like all of these up here do. All of them start with hydrogen. This starts with hydrogen. This is an acid over here. This will start with hydrogen. All right. So what I'm going to do is I'm going to write it down here because I need to cross the charges up. H+1, nitric. So once again, ic came from 8, so I should really be looking for not nitric, but nitrate, on my polyatomic ion chart over here. So nitrate is NO3 with a -1. When I cross those charges up, I just get HNO3 as my answer. Okay, nitrous, once again, us came from ite, so nitrite is what I should be looking for, which is NO2. So H plus 1, NO2 minus 1, cross those up, and I get HNO2. Okay, and at the bottom here, drawing Lewis dot structures. All right, so aluminum without any charge on it is 0. All right, aluminum with a charge on it, its charge is given with a +3. Okay. Number of protons. Aluminum will always have the same number of protons at 13. All right. Number of electrons. So because there's no charge on it, protons must equal electrons. 13. Right. Because there is a charge on it, how did it get a +3? Well, it got rid of 3 electrons, so I'm going to have 10 left. Right. If I do the Lewis dot structure of aluminum, it looks like that. Well, it got rid of all of those 3. That's how we got 10. Okay. Valence electrons. All right. So because it got rid of all of its valence electrons, it will have a full octet of the lower level. So it should have 8. Aluminum, how many valence electrons does aluminum have? Well, before it got rid of them, it looks like that. So this one will have 3. Okay. This, anytime an ion has formed, it should have 8 in it. 8, and it might look like 0 when you kick all of these off, but that means just a lower level is showing, and it should have a full octet, which is why I wrote the 8. Okay, so the Lewis dot structure here for aluminum is normal aluminum is that. The ion of aluminum should be Al with nothing around it. Okay, because it's gotten rid of all of those things. Okay, selenium. Let's do the Lewis dot structure first. Selenium is here. Where did selenium go? It's with oxygen, so to have 6, 5, 6, which means it wants to gain electrons to become happy. So selenium, when it does become happy with a -2, it'll be happy with a full set. Okay, so selenium here, because there's no charge, it's 0. When here, it's a -2. Protons, selenium will always have 34, no matter what. And then electrons, here, because it doesn't have a charge, it should have 34 electrons, the same as protons. Here, it gained 2 electrons to get a charge of -2, so this should be 36. Okay? Then when I do the valence electrons, well, selenium has 6, because I use the Lewis dot structure from the periodic table. Over here, it'll have 8 because it's gained 2. All right. Now, argon, down here at the bottom, argon's a noble gas, so it will not have a charge. Argon will always have 18 protons. The electrons will be 18 because these two equal each other, that's why that's 0. And then valence electrons will be 8 because it's a noble gas. And the Lewis dot structure for argon is that. Now you might be asking yourself, well, what about the ion of argon? Well, argon won't form an ion because it's already happy. It's already got that 8 in its ground state. These two will form ions because they're unhappy in their ground state. They're going to become happy when they form those ions. Okay. Now the one thing that I do want to add to this, there is no molar mass. So I'm going to do 1 molar mass problem. Okay. So what I'm going to do is this. So I want you can pause this video too to try to figure this out, and then I'll work it out for you. So you need to find the molar mass of acetic acid. Okay. So the first skill, once again, you can pause the video now and do that, or just keep listening if you have no idea where to go from here. So acetic acid, we first need to, anytime we find the molar mass, we first need to find the formula for acetic acid. All right. So acetic acid comes from acetate, which is C2H3O2 with a -1 charge, right? And because it's an acid, I should start with an H, +1. Well, when I cross those up, they cancel out, so I'm just left with HC2H3O2. Okay, so the first skill is being able to go from a name and into a formula. Now we got to take this formula and account for the mass of each one of these elements and the number of atoms per element. So what I should see is an organization that looks like this: hydrogen, carbon, well, there's another hydrogen, so I got that taken care of, and oxygen. How many total hydrogens do I have? Well, I have 1 here and I have 3 here. Total of 4. Carbons, I have 2. Oxygens, I have 2. Okay, so then I take that. Hydrogen is, I take it and multiply, so this is the atom number, right? This column. This next column is the atomic mass column. So hydrogen has an atomic mass of 1.008. Carbon is 12.011, and oxygen is 15.999. Notice how I did not round any of these numbers here. Okay, so then what I do is I take my calculator and I multiply these out. Okay, so I'm going to take a second to do that so I can get a full answer. So 4 times 1.008 is 4.032. 2 times 12.011, 24.022, and 2 times 15.999, 31.998. Then what I do is I add all of these up, add all of those up, and I get an answer of grams per mole. So when I take 31.999 plus 24.022 plus 4.032, I get 60.052 grams per mole as the molar mass, and make sure you have that unit right for the molar mass of that. Okay. The only other addition that I want to show you up here is if you have something like this, magnesium. When magnesium crosses, because magnesium has a +2, and let's say it crosses with phosphate with a -3. Okay, so you need to find the molar mass of magnesium bonding with phosphate. And so you need to make sure you have the right formula. So that I need to cross that down, I need to cross that down, which turns into Mg3PO4. That 2 came down, 2 goes on the outside of the parentheses. So now when I do my atom count per element, magnesium, phosphorus, and oxygen. Magnesium, that 3 goes with magnesium. Now when I do this, this 2 gets distributed to that and to that. So I have 2 phosphoruses, and then 2 times 4 is 8. And then I would go through and multiply it. So this is your atom count, number of atoms. This is your atomic mass number that you find from the periodic table. Multiply them out, add them together, and then you get a molar mass. All right, so I hope that helps.